Welcome to EFI Advanced Part 34. In this video, we're going to be taking a look at finding our maximum brake torque in our part throttle areas of operation. We're going to have a lot to learn, so let's get started. Okay, so let's jump into this video and talk about finding our maximum brake torque timing in part throttle areas of operation. We'll find that we want to have our spark timing optimized when we're in the light areas of operations. We're not at the higher load conditions at full throttle. It's going to be vacuum style driving. This can give us good throttle response, good torque output, and ultimately we're going to be improving our fuel economy. So there's going to be all positive things by going and figuring out what the optimal amount of spark timing is going to be in the lighter areas of operation. So there's going to be a couple different techniques and generalizations that we need to know about doing this process. Let's jump in and take a look at the very first thing we need to do in order to start our part throttle optimization of our spark timing. The very first step in our spark timing optimization process, part throttle, is going to be bringing our spark timing values down and having a baseline amount. That's going to be where we're going to be increasing from. Typically speaking, I bring it down to about 15 to 20 degrees depending on the engine and the compression I'm working with. So a higher compression engine, I'm going to bring it down to something like 15 degrees. A lower compression engine, something about 8 or 9 to 1 compression, 20 degrees would be a decent starting point. From here, we're able to increase our timing in small increments and evaluate data to be able to figure out if the changes we're making is going to be a positive change or it's going to be having no effect. And what we'll find is as we bump the spark timing in from this base amount, we're going to get to a point where we're going to have the optimization level where adding more spark timing in isn't going to be doing anything. We're not going to be getting any gains, and at that point we've reached maximum brake torque. Now the reason why I like to bump the spark timing down so low is because a lot of times if you're looking at a spark timing table, you would assume that the engine could run at something like 30 or 35 degrees, but in all actuality the engine might actually be performing optimally at maximum brake torque at something like 25 or 28 degrees. By going beyond maximum brake torque, you can have the onset of knock and pre-ignition occurring, and by going and having it further advanced timing, it's going to be giving you no benefit. So we only want to run as much timing on our engine as we absolutely have to, and that's going to be part of the cause and effect here by doing this calibration process, taking a look at our spark timing from a base level and then bumping it upwards and moving in small increments to see the cause and effect. The next step in our process here is going to be data logging some specific channels. Depending on what kind of engine management you're working with, you should find that you have your engine RPM, your vehicle speed, throttle position sensor, injector pulse width output, map sensor, and your ignition timing. So if we log all of these channels, what we want to see at a particular vehicle speed, we want to have the lowest throttle angle possible at the highest amount of ignition timing at the lowest injector pulse width output. We'll also notice that the throttle position and our map sensor are going to have a correlation. So if we have less throttle input, we'll be pulling more vacuum on the map sensor. If we have a higher throttle input, we'll be having less vacuum on the map sensor, getting closer to 0 psi. So we'll find if we have our factors, if we're kind of looking at all the data and we're keeping track of everything, we're going to be bumping in our spark timing. And again, what we want to find is that we have the most amount of torque available. If we have more torque available, that's going to require less throttle input. Our throttle is going to be open less. Therefore, we're going to have less injector pulse width. Therefore, we're going to have less fuel consumption and usage. And then ultimately, we'll have good throttle response as we're driving around. So we're going to have at every throttle angle or every throttle input we give to the engine, it'll simply have another 5, 10, 15 pound-feet of torque available, and it'll feel more lively. It's going to have better drivability. So we need to go in and monitor all these channels in order to evaluate our data. Now we're ready for the next step. So now we have our logging channels all defined and set up. We're ready to take a look at the actual calibration process and do the logging and capture our data and pay attention to what is going on. So we actually have two different calibration techniques that we can use to find maximum brake torque for part throttle areas of operation. The first is going to be if you operate your vehicle on a flat stretch of road. So you're not going to have any pitch or incline change. You'll be able to operate it at a fixed speed. Let's just say it's going to be 70 miles per hour. As you're driving down that stretch of road, you're going to pay attention to what your throttle is going to be doing. You're not going to give it any more throttle input. You're going to keep your foot fixed. You're not going to move it. And you're going to be starting to bump in the ignition timing and usually moving in about 2-degree increments. So as you bump your spark timing in, you'll find if your throttle plate is not moving, you'll start to naturally accelerate. And what's going to happen is you're allowing the same amount of air mass to enter the engine. That's not going to be changing because your throttle plate's not changing. But you're going to be going and igniting the mixture at a more optimal point. So you're going to be getting generating more cylinder pressure and therefore generating more torque out of the engine. By producing more torque, you're going to naturally start to accelerate at that same fixed throttle plate reading. And what you'll find is eventually, as you keep adding the spark timing in, you'll get to a point where the vehicle doesn't accelerate anymore. It's not going to be picking up speed. You might only pick up maybe 5 or 8 miles per hour, and that's going to be it. So you might go from 15 degrees spark timing to something like 30 or 32 degrees of spark timing. You'll find that it will simply just flatten out, and by adding more timing in, you're going to be going past maximum brake torque. And you might even start to see that you get some knock count or knock retard if your OEM ECU or your standalone ECU has that knock capability built into it. So this is going to be one way or technique that we can go about finding our maximum brake torque. Now the other way is going to be putting cruise control on or operating with the vehicle at a fixed speed, and you're going to be moving your throttle to maintain that speed. So as you drive, you're going to be adding the spark timing in the same manner, same stretch of road. It's going to be flat, no incline, no change in the pitch in the road. You're going to be simply rolling your foot back and trying to maintain that vehicle speed. So if it's 70 mile per hour is your target, you're driving along and you're going to be bumping the timing in. As you bump the timing in and you produce more torque, you're naturally going to accelerate, but you're going to be keeping it at that 70 miles per hour. So you're naturally going to be rolling your foot back more and more. What you need to pay attention to in a data log is as you go and add more timing in, what's going to be the point where you have the same vehicle speed and the lowest throttle angle possible. That's going to correlate to having the maximum brake torque. So it's going to be another way to go about doing this. Now this method is really easy to do if you have cruise control. So naturally the cruise control is going to be moving the throttle plate input to the engine. It'll be reducing the throttle if it doesn't need as much airflow or much torque production. It'll slow the vehicle down or maintain that particular vehicle speed. So in this case you want to maintain a speed, and you'll be watching what the throttle plate does in that situation, and you'll be looking for the lowest throttle angle possible while maintaining that specific speed that you've locked the cruise control in. So it's going to be a relatively simple method. So now that we understand the actual calibration techniques, whether it's going to be the fixed speed method or the fixed throttle method, we need to go into different zones in our spark timing table and operate in those independently to figure out where our maximum brake torque is going to be at. Then we can use interpolation functions to blend the rest of the table together. So typically what I do is I have a operation area at 2,000 RPM. Then I'll do another one around 3,500, and then I'll do another one around 5,000. I might have to go into various gears to accomplish this. I may not be able to do it in 5th gear, or I might have to go down to 4th gear or 3rd gear, depending on, again, if it's going to be 2,000, 3,500, or 5,000. But we need to be consistent in the either fixed speed or the fixed throttle method to be able to calibrate those zones. Now once we do that, we can do some interpolation. So we might go from our zone at 2,000 to 3,500 and do a vertical interpolation. So we're simply going to be blending the spark timing values and having an ascending trend as we go up in engine RPM. Then we'll find the same going from something like 3,500 to 5,000. We'll find the spark timing values don't vary a whole lot, maybe a few degrees. And then at 5,000, we can copy and paste that entire area of the row, and then we can paste it into the top RPM point or the top break point in our table, and then we can just fill the rest in. Typically, the spark timing demands at 5,000 aren't going to vary much as you go up in engine RPM above that. It's going to be pretty much tapped out, and that's why going from about 3,500 to 5,000 is going to be pretty similar in spark timing values. Only is going to usually vary a few degrees. Now we're going to have the problem where our lighter areas of operation, we weren't able to hit those. Usually, we can just simply copy and paste our column or the row, depending if we're working with standalone or an OEM ECU, or depending on how the fuel tables and spark timing tables are actually configured and laid out in the system you're working with. We can copy and paste that particular area and go back into the lighter throttle areas where we're essentially going to be lift throttle. We can usually run another 3 or 4 degrees of spark timing in that area because there's little to no load right there. So I can simply copy and paste, add 4 degrees, and then do a horizontal blend across the table and essentially blend it all in. Now we'll have an area from our 2,000 RPM going down to something like 1,000. We're going to have to do another vertical blend. It's going to have an ascending trend downwards. So what we'll notice looking at our spark timing table is that as we go up in engine RPM, it's going to be needing more and more spark timing. As we go up in engine load in our table, it's going to be dropping our spark timing back because we don't want as much cylinder pressure. But the goal here is to get our table built in the meat of the table, where we're going to typically be in normal driving conditions. The light throttle area is going to be near impossible to calibrate, but we can do the normal operation zones. And that's kind of how I broke it down here, looking at 2,000, 3,500, and 5,000, and being kind of in the middle of the spark timing table for the vacuum area of operation. This will be where you can get solid results by using either the fixed speed or the fixed throttle calibration technique and then get things dialed in. So for reference, if we're kind of talking about things in a general terms in most engines, 30 to 35 degrees is going to be a reasonable spark timing value that you should see in your table, around 2,500 RPMs and higher. Now, every engine is a little bit different, so depending if it's an old V8 engine, it might have a lot higher spark timing values. If it's going to be a really high compression engine, the spark timing values might be 5 or 8 degrees lower. So it's really going to depend on what you're working with. But generalization, just generalizing the spark timing values, 30 to 35 degrees is going to be a pretty acceptable range, what you'll find in the table, and that's what you're probably going to end up with after you do this optimization process.